Thanks for coming to this session. My name is Matt Lowrie, and I'll be talking about using Google 3D geospatial data, in particular with the SketchUp API. Like all the other sessions here, you can join the live wave and post questions. The link is here. I'll give you a couple seconds to jot it down if you want to follow it live and ask questions there. While you're looking at this, I'll just give a disclosure. I'm not showing any HTML5 or Android demos here. So nobody left, so that's good. So you're here definitely for geospatial data. So before I get into all the fancy demos, let's first answer the question of why 3D? Well, if you've gone outside recently and looked around, you'll understand that we live in a three-dimensional world, which is good because as humans, we inherently grasp the concept of three-dimensional space. And you know that if you've ever seen a dog try to walk through a plate glass window or a squirrel get a bucket stuck on its head in the woods, you'll know that as humans, we have this special ability to understand three-dimensional data. That, people getting stuff stuck on their head notwithstanding. But with that, we can use this inherent ability to understand 3D data to describe geolocated data or geolocated information. And I'm sure you've all used this in conversations that you've had with other people. For instance, if you're describing where your apartment is, you can say, well, I'm in the rounded building on the corner. Or if you're giving directions to somebody, you can say, well, that office is down the street. You want to look for the building that looks like a giant elephant. A few years ago, I was in New Orleans for SIGGRAPH. Not this past one, but the previous one, and a colleague of mine were touring around, and we wanted to find Anne Rice's house, who lived there at the time. She's the author of some of the vampire novels in the 80s, the previous vampire craze. So we asked a local on the street, how can we find Anne Rice's house? And his description to us was, you want to go 500 paces as the crow flies and look for the house, what you would think Anne Rice's house looks like. And from that description, we could make a mental 3D image in our heads, and we saw what we thought was Anne Rice's house. We're not sure, but at least we got a good story out of it. So that's the reason for 3D. Google understands this, and that's why we try to build 3D information into our geo products. And this can come in the form of 3D footprints of buildings on maps that you'll see in a lot of cities. This also pertains to Street View, which gives you this 2.5D vision of the surrounding 3D world around you. So you can get the same feeling of your three-dimensional space in this 2.5D environment. And that's just with a 2D product like Maps. Google also has a whole suite of products that deal specifically with 3D data. And that's what this talk will be focused on. These products are in order. Building Maker, which allows you to create 3D geolocated data from scratch. We also have SketchUp, which also allows you to create 3D data from scratch, but also lets you take data you've created in Building Maker or some other source, or data that somebody else has created, and refine that and build upon it and improve it, as you see. We have the 3D Warehouse, which is our storage repository for all things 3D. We also have Earth, which you're probably familiar with, which is a great product to actually visualize geolocated 3D data. These products are all located at these URLs. I was going to suggest that you could go to these URLs during my presentation, download them and play along with me, but then with all the bandwidth issues we've been having, I realized it's maybe not the best idea to have you download tens of megabytes of client applications while I'm trying to give my presentation. So after this presentation, at your hotel or at home, please go download some of these applications and give them a try. And that's where they're located. And with that, I want to mainly go into demos here. And let's hope I don't have a Google TV moment while I'm doing this. I'm going to go through these 3D products in reverse order and show you how each of them uses 3D geospatial data. And the first one being Earth. You're probably familiar with Earth, but if you didn't know, Earth also has a 3D buildings layer built right into it that I think comes turned on as default when you install Earth. But if not, you can turn it on yourself, and that gives you, I'll zoom into where we're located. What this gives you is the ability to go into any location and actually get the immersive feel of the entire 3D space as you would see it if you were there. So from this, you can see, what it would take to actually walk to different places and what different places are located around your area, what the perspective of buildings, the size of buildings, natural landmarks that you want to look for. Just show of hands, how many people knew about 3D buildings in Earth? Very good. Let the record show that that was most everybody for the YouTube audience. So yeah, you're familiar with that. One of the questions you may have had when looking at these 3D buildings is where do they all come from? And that's the next product, 3D Warehouse. So this is our online repository that stores all the 3D buildings that are located in Earth. They're contributed by users like you who want to build this geolocated data. You submit it to 3D Warehouse, and then it's taken through our pipeline to be considered to be put into the Google Earth 3D layer. You can see there's certainly lots of buildings, lots of collections of buildings, but we also store, any other types of 3D data, interiors, furnishings, cars, anything like that. It's not restricted only to 3D buildings. Any sort of 3D can be warehoused in this place. What's nice about 3D Warehouse as well is you actually have a user account to it in which you can see. It'll give you statistics on, did somebody download Earth? Because this is taking a long time. But it'll keep statistics on all the geolocated buildings that you actually store within here. So you can see how many you've actually submitted. It'll keep track of how many are actually in Earth at the moment. So you can build up nice scorecards of how much you've contributed to the 3D buildings layer that people around the world are using to visualize Earth. If you don't, it'll give you feedback saying that your building has been selected if it does get in the layer. If it hasn't, we also have reasoning in there that tells you, well, it wasn't accepted at this time for a variety of reasons, in which case you can go back and fix the model, try to correct any of the reasoning that might not have been included in Earth. This one was not accepted because we don't know if that building is there or not. That's a harder one to fix, but some of the other ones are easy if textures are missing or if your building's floating above the Earth. Things like that you can fix, and then it'll be reevaluated and put back into Earth. From here too, if you're just interested in buildings that are only shown within Google Earth, you can actually search for those buildings around any location. So this restricts the search to, yes, these are all the buildings that actually show on Earth now, and it's around this location that we're interested in. So if you go into any of these, you actually then have access to the model to view locally in Earth or to import into SketchUp for whatever 3D presentation you want to do beyond that. So there, and how about, show of hands, how about who's familiar with 3D Warehouse? A little less than Earth, but still respectable. I like it. Going backwards again, let's talk about the authoring tools. The first one being Building Maker. So this tool is relatively new, came out recently, but this allows you to create a lot of the building and 3D geolocated data that you saw in the 3D warehouse, all from scratch. You can do it right in a web browser. You only need the Google Earth plugin in order to use it. We check for that first, and you'll see why you need that in a minute. But what's nice about Building Maker is it is a Google property, but it's also a great example of using other geo APIs to build a geospatial product in itself. A couple of the APIs we use, I'll demonstrate here. The first one being the Maps API. Building Maker starts off by giving you a series of locations in which we have available to model right now, and we use that by the familiar map pins on the map of the world. And this lets you pick any of these locations that are available to model right now. I will pick my pre-selected location for this demo to show you an example of this. From here, we put the little blue measles all over the map, showing you places that people have models already pending to be in Google Earth right now. These are in the pipeline. So you know that all of these ones showing up here, somebody has already modeled. So from that, you can pick a new location to start building where nobody has touched it. So those markers were pending models. There's also models that are already in the 3D layer in Earth, and those you can see. You can see those by going to the Earth view, in which we highlight all the 3D buildings that are already in there. So this is a good example of using the Earth API. And this is why you need the plugin in order to use Building Maker. So with this, I can see what people have already modeled, and I know I'm not around pending models, so I can find a brand new location that nobody has modeled yet. And from this, I get a series of images at that location that are slowly loading. But if I pick this location, you're given a bunch of oblique aerial imagery, which you can then model on top of to create your 3D building. So if I zoom into this one, I choose this location, this building. We give you a series of primitives, blocks, very common for postmodern buildings. Different roof types, hip roof, gable roof, pyramids, flattened pyramids type roofs. Also freeform primitives. So that allows you to go into more, high-end architecture where they're doing all sorts of fancy shapes. The freeform shapes allow you to model those as well, which we have a lot of examples of. This one's pretty blocky, luckily, so I'm able to easily, right within the browser, just take a block, superimpose it over the boundaries of the building. I can then constrain where I want to put the next block on top of that one, And I'm going to add a flattened pyramid roof on top of there, and then I can constrain that to the roof profile very quickly and easily. And that gives me one perspective of it. I can then go through all these additional images that give me each side of the building. That was a little fuzzy. I don't like that one. Let's try this. Loading. Connectivity, slow. But if it had loaded here, I could then, in each of these views, they give you a different side of the building, which you use then to model. Here it comes. So I put that in place. As refined as I can. And then from here, I can preview it directly in the location in Earth. And what Building Maker will do is take those oblique aerial images and use that as the texture for your building on the sides that I constrain them in. So there's my textured building, which, oh, thank you very much. So you'll get, you can be as detailed as you want with this, with all the primitives that are provided. You can go in, model some of the roofing elements here, awnings, things like that, and the texturing service will then texture over all that geometry and warn you when you need to fix things like if you've missed some sides, it'll warn you, hey, go to those sides and texture those as well. But in the interest of time and in getting to lunch on time, I'll just save this one. And when you save it, it's automatically put into the 3D warehouse for you. It's put into the queue to be considered in the Google Earth 3D layer, and you're on your way. You wait. We try to get the process down to a week in order of notifying you, but after that, we'll let you know if it's accepted or not, and you can feel so empowered that you go and model entire cities. That's the hope. So there it is in 3D warehouse with mapping, street view, different information about what you've just modeled. So that's Building Maker. The other authoring tool that we have, and the one that relates to this conference, let me quit out of Earth to save the GPU and go into SketchUp. We have SketchUp, which is another authoring tool, lets you easily create 3D geometry from scratch, allows you to import 3D data like the building you just created in Building Maker. And what it also provides, which relates to Google I/O, is an actual API to get at all of that 3D data and geospatial data as well, which I'll be going through and blasting a whole bunch of code on screen. So if you're in the back, you may need to squint. So here's SketchUp, and there's several ways to access the API. The SketchUp API is actually in the Ruby programming language. We've compiled in an actual Ruby interpreter within SketchUp, so you can access that either through an interactive terminal, in which you can, in real time, access the entire 3D scene from the API. You can save your code out to an actual Ruby script in which SketchUp can load that whenever you define. as I'll show, it gives you access to the GUI, so you can have build your plugin into the GUI and have a user invoke it whenever they feel like it. Another way you can invoke it, which I'll demo, is that from the command line of launching SketchUp, you can tell it to load a Ruby script, and it can load that at runtime and actually batch process jobs. So I'll demo all those. Let me go back to the slides real quick. And first show where SketchUp API exists in the maps or the Geo API landscape. And you can see it's down here in the bottom corner in nice ruby red. It's not built on any of the Google Maps infrastructure, but as I'll demonstrate, it works very cleanly with any of these other APIs. As an introduction to the API as well, I want to go over some of the terms that the SketchUp API uses that might be different from what you're used to, either working with 3D or or with Ruby specifically. If you're used to 3D, you know you have a 3D environment or a 3D scene. That's referred to as the model in SketchUp. Within that model or 3D scene, you have all your 3D geometry. We refer to those as entities. We have vertices, which are points in space, three-dimensional space. We call those vertices or points. We have edges, which are the line segments that connect vertices to create actual defined areas in 3D space. We have faces, which you're probably familiar with. Faces are just polygons that are defined by these edges or line segments. We also have the concept of a loop, which is the series of line segments that go around a face. So I'll demo all of those directly in SketchUp so you can see what it's all about. So I'm going to pull up a special interactive console that will give me direct access to the Ruby interpreter and the actual SketchUp scene that I have right here. Right here, it's empty right now, but we'll fix that. So I mentioned model, and that we have a SketchUp top-level module. If you're familiar with Ruby at all, it deals with modules, which are basically namespaces. So we have the SketchUp namespace or module, and from that I can get the active model, which is the entire 3D scene. Let me pump up. Can you see, is that visible? So I have the model in this local variable m, and I can check the entities, which are in here right now. Right now I have nothing because it's an empty scene, but on that entities collection, we have helper methods, entities, very verbose. I can add a face, and if I want to add a four-pointed face, I can just give it an array of three-dimensional coordinates. So I'll start at the origin. I'll go out 100 units. Make another one at 100, 100, but I'll stay 0 in the z-axis and back around. And this will return the face that I'm creating, so I'll store that as well in F. So add a face, Ruby takes the command and puts it in my 3D scene. SketchUp, what's nice about SketchUp too, and what makes it easy to create 3D within it, is we give very conceptual 3D tools. So we have things like eraser to delete geometry. We have squares and circles, which are easy to understand. We also have this tool that's called a push-pull tool, which allows you to quickly and easily extrude 3D geometry from any 2D primitive. And that same terminology exists in the Ruby API as well. So on my face, I can actually push-pull it. The direction of the normal of that face is pointing down as I created. So if I want to push-pull it up 100 units, I'm actually going to go negative here, and that'll give me a cube. And just to be interesting, what I can do now is iterate using the Ruby syntax over all the entities in the scene. Ruby allows you to call each if you have in a collection and give it a code block in which you can operate on any of those elements. So I'm going to iterate over everything in my entity scene now, which, if I do a count, I now have 18 entities, which includes all the edges and all the faces. So if I iterate over all of them, I'm going to get each entity. I'm going to check if that is a SketchUp face. I'm going to set the material to a new color. And I'll just take random values for that. And then, so if I do that, then I can just iterate over everything that's in a face in this scene and give it a random color. The random colors weren't that interesting, but oftentimes it is. So other things you can access here, which are nice. Face has its collection of edges. That is length. So 4 edges around that face. If I look at each of those, or if I look at an actual edge object, I'll get the first one. The edge object has its 3D data, like a position. Did I get it? Yeah, got the edge. Position. I didn't do it. But it has positional information contained within that position. I know what I need to do. Actually, so an edge has 2 vertices. You want to get the position of those vertices. What's nice about Ruby is that Ruby is a language that tries to give you some human-readable context, which is the reason why we used it as a scripting language, because it makes tries to make your scripts human-readable. So for a lot of these terms for 3D, all the 3D geometry in here, we can actually use human-readable terms. So an edge, which is a line segment, has 2 vertices, one on either end. We can actually store those in methods called start and end. And those are what you'd think of if you're thinking of a line segment. And actually, if I look at the position of that, did I spell it right? There it is. Okay. So the start position is at the origin. I can look at the end position of this line segment. And that's the one that goes from 0, 0 to 100, 0, 0. So with this, then you can easily look at this face. I want to get the length in X. So for the face, I'm going to look at the edges, get the first one. First edge, I'm going to get the length of it. That's 100 units, as you would imagine. If I'd made this asymmetrical, it would have given me different, but if I get the next edge in order, and get its length, which is also 100, I now have the length of one side of the face and the length of the other side. So from that, I can just multiply and get the area of that face. So this is an easy way. If you're given any sort of 3D geometry, you can inspect it, actually calculate things that might be interesting for geolocated data like areas and volumes and things like that. But as I mentioned, Ruby allows you to define all that in human readable terms, so face already has area method on it, which gives you that same information. What it doesn't have, though, is volume, which is easy to get as well. What we need there is just to get the length of any of these edges that go up in the z direction. And from those, the way to find those is if we iterate over all the edges and find out the ones whose start vertice at z position does not equal the z position of the ending vertice, then we know we have one of these line segments. So from that, I can get the face. There's an all-connected collection, which gives me all the entities that are connected to that face. I can iterate through each of those. As I'm iterating through those, I can check if it's an edge. Is this a SketchUp edge? Before I do that, what I want to do is define LZ so I can store it in there. So my face, I iterate through all connected, each. I'm going to look for, is this a SketchUp edge? And if so, does the start, automatic screensaver. If I look at the start position, the Z, if it does not equal the end position in Z, then I know that's what I got. So I'm going to store the length in there. And just to make sure this works, you might want to turn off your Bluetooth or that. I don't know if it'll help, but we'll see. Syntax error. Oh, I forgot an end somewhere in there, so let's get it back. Do end is edge and en position z. Thank you. Now that guy's awake. Thank you very much. There we go. Iterating through all of them. I get the length of that. Now I have the length in x, y, z. I get my volume. So there we go. There's examples in real time of how to work with 3D data within the API. So that's basic 3D geometry. Let's go over some terms that are specific to SketchUp and not just 3D in general. And this will show us how we can get at actual geospatial data. SketchUp has this idea of a component, which is basically like an object class instance relationship. So you can have this ideal definition of a component, and then within your 3D scene, you can instance it all around. It will always refer to that ideal definition of the component. We also have an attribute dictionary, which allows you to store custom data into your model. That way, when it gets saved out and passed around and given to somebody else, you can look in those attribute dictionaries, which are just key value pairs that store whatever custom information you want to keep with that model. We also have a web dialog, which, as the name suggests, is just within SketchUp, gives you a web browser. So I will demonstrate each of those. We'll start with a new scene here. I'm going to import an actual KMZ model. So this came out of the 3D warehouse. I can just import it. And this is a good example of how to demonstrate this component and component instance relationship. So since I started a new scene, I'll get that active model again. The active model has its definition list in definitions. So if I look at the count of that, there's one ideal definition in that definition list. And if I look at what that is, the one object in there, it's my component definition. If I look at entities right now, there's one entity in there. And if I look at what that is, that's my component instance. And what this relationship gives you is if I take this and duplicate it, any edits that go on to this now, let go. Any edits that I do to the one will take place in all the others. So that's what components are all about. And you'll see that if you bring in KMZ files, they'll be set up as a component to start with, which is why I'm explaining it here. So let's look at attribute dictionaries as well. Let me start another new one, and I'm going to import another building. Oh, actually, that's a model, so I don't have to import it. I can open it. I got the Trump World Tower here. There it is. So this was also got off the 3D warehouse. And somebody built it in a geolocated position. I have a sample of a environmental skirt here, which shows the location that they actually pulled it from. So this is where it all ties together as far as using the Lowrie API with geolocated data in the attribute dictionaries that I mentioned. Let's get the model again. Oops. The active model has this very, very, very long term associated for getting attribute dictionaries. And these, as I mentioned, are key value pairs. So since it's so long, I'm just going to store it in this member variable. Let's look at what each of these keys are if I get each item in this attribute dictionary. So I'm going to put the name of each one that's in here. So this comes with a couple dictionaries of custom information that was included with it when I pulled it down from the 3D warehouse. The most important here being geo-reference. So in the attribute dictionaries collection, any of the ones that are geo-referenced in the 3D warehouse is going to have this geo-reference attribute dictionary. So if I get that, reference, I won't go over everything in it, but it has what you would probably want from georeference information. We've got the latitude of where this is located and longitude. So I can store each of those. Let's get the latitude. Longitude. Now that I have those stored, what I can do is take that web dialog object that I mentioned. I'll create one of those. That's in the UI namespace or module. Create a new one of those. The web. There we go. That's better. Now that I have one, you're an excellent wingman, if I hadn't mentioned it. I get the web dial. Let's set a size that's big enough to see for this screen, so 1000 by 800. Let's just show that it's there. That looks big enough. So now I can set the URL on it. And I will use maps.google.com, maps. I'll set the lat long and use Ruby variable expansion here to set my lat and long. Is that what I used? Hold on, yes. So I got that. Let's set hybrid and zoom level into 19. So I'll set the URL to that. Here's my web dialog within SketchUp. Sets that lat long of the Trump Tower, and there it is, right there, Trump World Tower. So I can actually, once I have a model, I have different tools for visualizing where it is. So here's my web dialog. It's easy to put maps into there. We're dealing with 3D though. What would be even nicer, as you would extrapolate, is that we can put in the Earth API browser or web browser plugin. And that's what we've done with this plugin. So I've taken the Ruby script in order to do the same thing I just did here, pull up a web dialog, embed the web or the Earth browser plugin, take the lat long of this model, show it, and also decorate it with other HTML. But what I did was save this in a Ruby script that when SketchUp loads, I get access to the SketchUp UI, and I can actually put it in this menu item. So now the user can invoke this script at any time they want by just going to the plugins menu and invoking it. So from that, I'll actually invoke my script, which creates a web dialog window, builds it with just basic HTML, takes the lat long of this model, puts it into an Earth plugin, decorate it with whatever your client needs are. And that way, what's nice about this is you have, 3D visualization right here for whoever you're showing it to, but say you're showing this to somebody and they come, in real time, they say, no, I want it to be huge. Well, then you can take it right there, build it out, preview it again. There it is, new. And your client is just as impressed with these as he is with Bret Michaels' bandanas. So there you have it. One last demonstration that I want to give here. There's lots of scripts actually out on the web. There's a website called smustard.com, which is a warehouse for different Ruby scripts that people have given for free. The name of that comes from SketchUp is SketchUp, so this is smustard. They store a lot of scripts out there that you can browse and use. One of them is a neat one. Let me import another building here to demonstrate it. This script was written by a user that actually, and let me explode the component here to demonstrate it. This plugin can actually take geometry and unfold it. So whatever three-dimensional object you have in there, it'll give you an unfolded template for it. Well, this exists in a Ruby script that I can then use to batch process SketchUp by using, if I call SketchUp with this -Ruby startup command line flag and point it to the Ruby script that does this, I can actually, yes, I know, I quit it. Thank you, Apple. I can actually do batch process any unfolding of buildings that I want to do. If we take a look at the script real quick, because this is Ruby, and because this is a plugin architecture that people accept to actually install into SketchUp, I actually, through Ruby, have access to the file system. So I can look at a directory of KMZ buildings, iterate through each of those, get my active model, import each of these buildings that I'm iterating through off the file system into SketchUp, look at it, call my unfold script on it. I can change the camera view to look straight down from a top view. I can zoom, extend so that I've got the entire thing in view. And then I can save all of that out to PDF or PNG file or whatever I want to do. That's on my file system here. I've got my buildings. I've got this printouts. Let's delete it so you know that there's no magic. And if I just invoke this script with Ruby or with SketchUp, let me switch to SketchUp so you can see what's going on. This will actually use SketchUp to batch process 3D geometry by just executing the Ruby script that I give it. So there's all my buildings, went through, unfolded them all, checked the file system. There's all my printouts. There I can batch process, send them to the printer, and all those to the intern to cut out and build into actual 3D paper models. And everyone goes out for beers because it's done so quickly. So that is an introduction to all things geospatial 3D. Thanks for coming, and thanks for delaying your lunch to see all this. I appreciate it. And we'll take any questions you have. Yes?
I was going to ask in Builder Maker, you have multiple views, multiple angle views. Obviously, it was a subset of Amsterdam. Kind of two related questions. One of them is, what kind of defines where do you get the multiple angle views? And as a follow-up, is there any complication of using that technology with Google Earth Enterprise server so long as we can connect up to cage.google.com?
Yeah, so the question is the oblique imagery from each side in Building Maker, and if using that with, if you use that to texture, if you then take that building into Earth Enterprise?
Yeah.
Yeah.
Well, actually, the first question is what defines, you don't usually have multiple oblique views. I noticed in Amsterdam there was a subset. how do we know which areas, or what causes you to have multiple views of the same area?
Yes, so what causes you to have that, well, all those, how do we give you all those multiple views
Right.
when you're building at that location? And the answer is, that's a secret. No.
Right?
But no, better answer to that is that's just part of the product of Building Maker. So we, actually Google owns that oblique imagery, and that's certainly all geolocated as well. So when you use the Maps or Earth API to pick a location that you want to model, we actually can derive that information where you are and then figure out what obliques you need for that particular area. And that's what Building Maker provides. We just put that into the application to give you all that, and then that's used to texture map.
Is there any way to replicate that capability on our own Google Earth Enterprise server that's?
There isn't.
Okay, thanks.
But as far as...
I was hoping you were going to say yet.
I can't say yes at this
Not
time,
yet.
but the answer to if it works with enterprise is yes, because we then take that and use that as a texture map on the building. So once it's on the building, it's actually removed from that oblique imagery, and then it's just a texture model at that point. So if you use it with regular Earth or enterprise Earth, it'll all work the same.
Hi.
Hi.
Since we're not in the Android room, I'll ask an Android question. Is Earth supported on Android, the API? And can you do this? Like, for example, could I have a 3D map of a building, and let's say I want to go to that building, then maybe I would press on the upper floor. I could get like a little layout that would show me the inside of the building, things like that.
That would be super awesome. Which you might consider building. Yeah, at this time, there is, and I don't want to say the wrong thing, I believe Earth for Android, or, yeah, I'm actually not sure what's available, but
I know
all
they
of
have
this,
maps, yeah.
all of this I know is not available on Android yet.
Okay.
Yeah, I don't know when.
I mean, we've done 3D rendering like in a game, and then you're doing all kinds of matrices, and this seems so much easier that you could just pull up stuff and.
Yeah, it's certainly the way. There is, I know a lot of 3D in general, there's a lot of momentum building up in different areas of it. So some of it is figuring out which technologies are right to go to these platforms with. There's WebGL that's emerging,
Right.
and
OpenGL.
with the Java built in for Android, there's options there.
Oh, okay.
So as far as getting it to these different platforms, some of that is just finding out what's the best way to do it. The desktop is at that point to where we can do stuff like this because the graphics have just, over the
it's
years
already-
have
Okay.
matured enough. Hopefully I answered your question by saying nothing.
What determines which locations Building Maker is supported in, and is that increasing at a certain rate?
It is. It's basically, yeah. We collect that data. So, and we don't. We want to make sure it's accurate data. It's good. It's good quality data to use. So that determines what's actually available at what particular time. It's currently available right now for 89 cities around the world. Since we've launched, it's just a progressive stream. We launched with way fewer cities, and then, whenever we get data in the pipeline that's quality enough to present, that's when it'll show up in Building Maker.
Hi.
Hi.
I was just wondering, this seems like it only works in Earth right now. Is there any push towards making it work with all of the Maps APIs as far as the perspective 3D models go?
As far as the Building Maker? Right. That is, the resulting buildings certainly work with Earth or with any, they're available from 3D Warehouse to work with anything. As far as the interface for creating them, That's only available within Building Maker. And
I
it's-
guess I mean taking these 3D buildings and putting them in the Maps API so that you could see them, you know, kind of make them available to more people.
They should, yeah, it should be the same. We just launched Earth View in Maps, and through that is the same collection of buildings that you see in Earth. So if you go to Maps now and turn on the Earth View, you'll get the same buildings available in Maps. That, in order to access them, I would imagine you have to go through the Earth API in order to, you know, present whatever view within Maps. But it's the same. I'm not sure about Android if it's the same, but yeah, if you go to desktop, go in a browser to Maps, you'll turn on Earth and see the same view.
Thank you.
Does the Google, this building maker, does it have an API?
It does not have an API as of yet.
Does it allow you to save a building as a KMZ?
Yes, so that's what automatically happens.
Okay.
When you save a building in Building Maker, it's directly put into the 3D warehouse.
I don't want to put it into 3D warehouse. That's the point.
Yeah,
I want
that's
to save it as a KMZ to my C drive or whatever.
yeah. There's no way to go directly from Building Maker to say just download it. The process that actually converts it to KMZ runs on 3D warehouse. This is why it's actually put in there. That is what converts it to KMZ, in which you can download it from 3D warehouse. In which case, if you don't want it in 3D warehouse, at that point you could just delete it from 3D warehouse.
Okay. The oblique images they're only available within Building Maker. I can't go view 3D images from Google Maps, Google Earth, or any other Google product. True?
Correct. Yeah, they're only.
Why would that be? I mean, I can go to Microsoft Live Earth or whatever, get obliques there. I work for a local government. We spend $50,000, $100,000 a year buying oblique images. I mean, why wouldn't you make these obliques available in the standard viewers?
The answer to that is many faceted,
All
many
right,
of which
but-
I don't have the facets to answer. But it is, yeah, currently it's just available in Building Maker, and that's because we have this particular use case for it.
Is there any means to add interior information about buildings, like floor plans?
Yeah, that's certainly a big, on a wish list of many people. So it's certainly on our roadmap, but currently, yeah, this first implementation is obviously just exteriors, but something we're always, researching.
Thank you.
Sure, thank you. Thanks. It looks like there's no moderator questions either. And I think we need to wrap it up to get back on schedule. So if you have any more questions, I'll be at the back of the room.